Hello there. I'm Mr. Warrior once again here to talk about the operating system now in detail. This is lecture 3. So sure now you know what an operating system. From the previous lecture we defined what an operating system is, what are the functions of operating system, examples of operating system, and also the different types of operating systems that we have. Okay, so make sure you have a book so that you can be taking note of the most important concepts, so that you'll be able to connect and also be able to remember most of the things under the operating systems. Okay, let's now dig in. So now to start with, today we'll begin with the types of operating system, of which I'm sure by now you already know. Okay, so now the first type of operating system is the single program systems. So if you remember clearly the single program systems, we defined what a single program system is. We also gave examples. We also gave advantages and also disadvantages of the single program systems. So now the reason for this recap is that so that you should be able to remember where we are coming from and also be able to connect where we are going, so that no one is behind. All right, so the second operating system we're saying is the simple batch system. We also did the same. We defined what a simple batch system is. We gave examples of the simple batch systems. We also gave advantages, disadvantages of the simple batch systems. Okay, the third one we're saying is mount access and time sharing sources, real-time systems. Okay, so now for these operating systems which are here, these are just few of the operating systems that we have, but they are a lot. So these are the necessary ones. Okay, so now the diagram here on the right hand side is helping us to, it is rather showing the 5 types of operating systems that we have. Okay, the first one is the batch operating system. The second one is time sharing operating systems. Third one, distributed operating systems. Fourth one, network operating systems. So this one, I'm sure you remember something from the word network. Okay, so we also have the last one, which is the real-time operating systems. Okay, let's now make progress. Okay, so next is remember also that we defined, we did the introductory part to application softwares. So now today we'll be able to look now into details of what an application software is. Now before we do that, let's start with the definition of an application software. An application software, by definition, we are saying this is a software or a set of computer instructions that are written in a programming language. So a set of instructions, meaning it has got instructions that are assigned for it to be doing specific tasks. The second one, we're saying the instructions direct computer hardware to perform specific data or information processing activities that provide functionality to the user. Okay, so now the same functionality that we're talking about here, we are saying this functionality, it may be broad, such as general word processing, or narrow, such as an organization spell. So now before we proceed here, look on the left hand side where there is this diagram. So this diagram, it is showing different examples of application softwares. So when they say by functionality may be broad, this is what they mean. So we can have different application software examples but performing different tasks. Okay, so an application program, it applies a computer to a need such as increasing productivity of accountants or improved decisions regarding an inventory level. Application programming is either the creation or the modification and improvement of an application software. Okay, so now we move on to first, before we go to system software, so let's now look at some of the examples, practical examples under the application software. So application software, we are saying an example of the given that those examples. So now an example of system software would be the Windows operating system. So now we are now talking about system software, which, if you remember properly, we defined what it was by definition. Also gave a bit of examples, though we didn't look much into details. Okay, so now today, before we start with the definition, let us first look at the examples of a system software, so that you can be able to even relate when we define what a system software is. Okay, so we are saying the first one, it is Windows operating system. Using the system software Windows, you can operate application software such as Microsoft Word. So now from this example, or under the system software, you can be able to say that the system software does not depend on the application software for it to run, but the application software depends on the system software for them to be able to run or to perform their tasks. Okay, let us now define what a system software is before we go into details. So system software, we are saying, is a type of computer program that is designed to run a computer's hardware and application programs. So it is designed to run computer hardware and application programs. So the computer hardware that we're talking about in this case, it is able to coordinate the hardware part to work together with the software part. So the hardware part, we can have the keyboard, the mouse, and also other devices that may be connected to the computer. Okay, so now, and the application programs, these I'm sure you can give you even examples on the application programs just from talking about them. So the application software like Microsoft Office, Word, PowerPoint, Excel, Publisher, Access. So all those are examples of application software that cannot run on their own, but they depend on the system software for them to be able to perform their tasks properly. Okay, so if we think of the computer system as a layered model, so the system software is the interface between the hardware and user applications. So it is the interface between the hardware and the user applications. So like we said earlier on, so the system software, for example, an operating system, it is responsible for the coordination of the hardware and also the software part. Okay, so we move on to the third point, which is the operating system is the best known example of a system software, like we said earlier on. So system software is a type of software that is designed to provide a platform for running and operating other software. Namely, some of those examples are examples of the softwares that run on the operating system is, we can say, an application softwares, different softwares that are designed to perform different tasks. So you need system software to run application software. This is where now why I was saying, for us, if we cannot learn application programs minus having the system software. So application software depend on the system software for them to run, but the system software does not really depend on the application software for them to be able to run. Okay, go to the next slide. So we are saying examples of system software here. Okay, First, I will go over some system software examples, and some of these system software examples are very well known, while others might be less well known. Okay, so the first one is the Windows. Under Windows, this is where we find the what? The Windows operating system is perhaps one of the most well-known system software. Many laptops and desktops, they use the Windows OS. So the Windows OS, these are basically the Microsoft Windows, such as Windows 7, Windows 8, Windows 10. This time there's even now Windows 11. Okay, so the second one we are saying, using the Windows operating system, you can install various application software such as the Microsoft Word, Google Chrome, and also Firefox, and many other applications. The third one we are saying, the vast majority of computers run on Windows, with more than 75% and up to 87% of computers using Windows. Since Windows interacts closely with your device's hardware to run applications on it, it is the system software. So now, if you don't have Windows, Mac, or another operating system installed on your device, or rather your computer, you won't be able to do anything on your computer, let alone learn application software. So you cannot learn these application softwares minus the system software. Okay, so now the second closest operating system is the Mac, which is popular also, but only makes up a smaller percentage of market share. Okay, so now let us also now talk about the programming languages part. So before we go to the levels of programming languages, let us first look at the programming languages definition. So programming languages, by definition, we are saying these are the basic building blocks for all systems and application software. So programming languages, they are basically a set of symbols and rules used to write program code. Each language uses a different set of rules and the syntax that dictates how the symbols are arranged so they have meaning. Okay, so now the characteristics for the languages depend on their purpose. Languages also differ according to when they were developed. Now today's languages are more sophisticated than those written in the 1950s and also the 1960s. Okay, so now, having looked at the basic introduction to programming language, let us look at the levels of programming languages, which will be able now to elaborate more then as we go on in this lecture. So programs written for a computer may be in one of the following categories of languages. So the language can be written in machine language, assembly language, or the high level language. So now, don't worry about the machine language, assembly language, high level language. We'll also be able to talk about them in detail as we go on in this lecture. Okay. Now, the introduction, this part will just do the introductions, and then later on we'll look at them in detail. So the machine language, we are saying this is a sequence of instructions that are written in form of binary numbers consisting of zeros and ones, which the computer responds directly. Okay, so by zeros and ones, we mean the computer does not understand the normal English that us humans are able to understand, but it understands information in form of binary, which consists of the zeros and ones. Okay, so computer hardware recognizes only this type of instruction code. The advantage is that it's fast since the computers execute it directly. The disadvantage part of this machine language, we are saying it's difficult to understand and develop a program using machine language. Okay, so that's it about machine language. Let's go to assembly language. So when we employ symbols, for example letters, digits, or special characters for the operation part, the address part and other parts of the instruction code. This representation is called an assembly language program. So machine and assembly languages are referred to as low-level languages, since the coding for a problem is at the individual instruction level. So you'll be able to understand what this statement means as we go on in this lecture. So each machine has got its own assembly language, which is dependent upon the internal architecture of the processor. Okay, so we continue. An assembler is a translator which takes its input in the form of an assembly language program and produces machine language code as its output. The high-level language, so the time and cost of creating machine and assembly languages was quite high. This was motivation to develop the high-level language. So since a high-level language source program must be translated first into a form that the machine can understand, so this is done by the software which we are calling the compiler. So now, if let's for example, this is a keyboard, right? You type maybe THE, which is there. The computer does not understand the THE though. No, it will need some applications to be able to translate or to quickly convert the THE into the binary digits, which is the zeros and ones, which the computer is able to understand. Okay. So during the process of translation, the compiler, it reads the source program statements twice and checks syntactical errors. High-level languages, they offer readability, portability, and also easy debugging. Okay. So now let us look over the summary law of an operating system. So basically we are not talking much about the laws, because we already talked about them in the previous lecture. So here we are saying an operating system is a system software that manages the general operation of a computer system. So this is the law of an operating system. So you've seen the purple arrows where they are pointing. So these are the laws of what? An operating system. So just a quick one. So the first one is saying it helps the user interact with the computer through a user interface. So this is an example where the Windows button is the Windows is shown here. It also provides security and prevents unauthorized access to a system. So you're able to put a password, a PIN on your system so that you protect it from no one can access it without your approval or without your details. Okay, so that's what we mean by it provides security, and also try to kick out those that are not supposed to have access to your system. The third one, we are saying, allows users to load, run, and store applications, also resolve errors occurring in applications, helping save, organize, find, and delete files. Okay, so this part we'll be able to do it in a bit of practical, so that you understand how we can save, organize, find. So finding meaning we were able to search for the files that we are looking for specifically, and then they come. And also we're able to delete files. So I'm sure you know how to delete files, but we'll be able to do a bit of practicals just for the sake of others who still don't know. Okay, so decided what should be loaded and deleted from memory. It also manages input, output, and also backing devices. Okay, we make progress. Examples of the graphical user interface operating system, which is usually abbreviated as the GUI or the GUI. Okay, so now here are the examples. So the first example here with the one in the blue button having four colors: blue, red, yellow, and green. it is representing the Microsoft Windows operating system. Okay, here then these are the examples. This is Windows 7, the next one is Windows 8. Then we've got the X here, which is representing this type of window. We've got Linux. So on the Linux, we gave different examples under Linux, where we said this is where we find operating systems such as Ubuntu operating systems, Fedora, Elementary, Kali Linux, etc. Okay, so other examples, these are the other examples in form of pictures. I'm sure they are now self-explanatory. Okay, so the GUI. What is the GUI? So I first gave you examples in form of pictures so that you know where we are going. If possible, I'm sure you are even able to come up with the definition of the graphical user interface. So now in this slide, we're going now to explain, or rather define, what a GUI is, or a graphical user interface is. So we are saying is an user interface that is built around graphics. So for example, Windows areas for displaying information. So this area where the orders are being displayed, this is called what? The GUI, the graphical user interface. It is able to display things in form of graphics, pictures, and all that. Okay. The menus list of options or applications users can select from. So these are some of the examples that are presented under the GUI, the graphical user interface. Okay, so we also have icons. So icon, small images that are used to represent files of folder or applications. So these are the examples of the icons that we have. Sure, if you look at any Windows or any device with an operating system installed on it, you should be able to see some of the folders or the shortcut pictures, small pictures. So those pictures, we refer to them as icons, that they represent files, folders, or other applications. We also have pointers. So mouse pointer can be used to select and open files, applications. GUI are quite easy to use due to the visual nature of the interface. So now what they mean here is, for example, you see this, the first example is the folder. You see the folder. If you want to open the folder, you can just double click it, it opens. Or if you want maybe to rename the folder, you can just right click. So that's very easy to use compared to the other user interface, which is the command line interface. So for the command line interface, mostly it deals with commands. So if you don't know commands, meaning it will be very difficult for you to be able to use it. But with this one, since it displays icons in form of images, you are able to read and also be directed what you're supposed to do, to maybe for the certain folder, if you want to delete, or if you want to rename the folder. Okay, so now the user has lots of visual clues as to what things do. Okay, so we go to the other type of interface, which is the command line interface. Okay, so now under this command line interface, this one is different from the graphical user interface. The previous one, we are saying it is able to display icon files or folders in image form, but this one is different. So how is it different? Now let us talk about the difference. So the command line interface, which is also abbreviated as the CLI, it requires the user to enter command prompts to interact with the computer. So the command line interface are normally used by expert users as it allows them to is more complicated to use. So the CLI and is not restricted to a number of predetermined options. So long the user knows the commands, he or she can be able to do a lot of things to the computer or the device. Okay, so this black thing, it is an example of the command line interface that is used. So this is where the commands are typed. Okay, so example of command prompts that we have are R3, which displays or changes file attributes. The CD displays the name of the current directory, so CD is for current directory, attrib it's for attributes. CHKDSK, it checks a disk and displays a status report. Maybe let's say the disk is not okay, so it should be able to display, scan and check what the errors. So the CHKDSK, it's simply for checking disk. Copy is one or more files to another location. So you know how to copy. For example, you want to copy a folder or a file from this folder and paste it in a different or another folder. The dir displays a list of files and subdirectories. Okay, so now from here, I'm sure I should be able now to differentiate between the graphical user interface and the command line interface. You'll also be able to give examples. Okay, I'm sure it's understood now. Okay, make this. So now the differences. The first difference we are saying the graphical user interface. So here we use the advantages and also disadvantages to differentiate the two. So under the graphical user interface, we are saying the user does not need to run any commands. While under the command line interface, we are saying the user needs to run commands, has more freedom to use specific command in interacting with the computer. So the interface under the graphical user interface, we are saying is easier to use because mostly they are displayed in icon form. While for command line interface, you just need to know is how to use the commands and which commands to use. Okay, so we are saying under the goal that you can use a pointing device to click and select icons or the menu options. But with a command line interface, there is nothing like that. Okay, so advantages of the user interface. So takes up more memory than a command line interface, requires an operating system for it to be able to operate. So when we say it requires an operating system, you know what we are talking about this time now. Okay, so the disadvantages of the command line interface, we are saying user needs to run commands. Commands must be typed in without errors. So any error that is typed, meaning the computer or the instruction won't be clear, hence the computer won't be able to respond according to what you want it to do or respond. Okay, then the last third part on the command line interface, we are saying there are no visual aids, it's just the CMD. Okay, so operating systems concepts. So here we will now list the different concepts of an operating system. So the first one, we are saying process. Second one, deadlocks. Third, memory management. Input or output device, file, and the last one, which is security. So now in this lecture, I'll be able to talk about each and every operating system concept in detail as we go on. Okay, so make sure as usual you have somewhere to be writing, to be taking note of the important concepts, because most of the things which have been explained here in this lecture they're not in these notes. So I'm also adding some of the like examples just to make you understand what we are talking about. So make sure you are writing those examples. Okay, so we start with the first one, which is process. So now a key concept in all operating system is the process. How? So a process is basically a program in execution. Associated with each process is its address space. So a list of memory locations from one minimum, which is usually 0, to some maximum, which is the process can be read and write. The address space, it contains the executable program, the program's data, and its stack. Also associated with each process is some set of registers, including the program counter, stack pointer, and other hardware registers, and all the other information needed to run the program. Okay, so we continue now with the process. We are saying time sharing. So time sharing under processes, we are simply talking about programs that are being run on the machine or the operating system to be able to share time in terms of their processing. So periodically, the operating system decides to stop running one process and start running another. For example, because the first one has had more than its share of the CPU time in the past second, when a processor is suspended temporarily like this, it must later be restarted in exactly the same state it had before it was stopped. This means that all information about the process must be explicitly saved somewhere during the suspension. For example, the process may have several files open for reading at once. So several files, maybe for example, you can open a PDF file, Word document, PowerPoint at once. That associated with each of these files is a pointer giving the current positions. Okay. So when a process is temporarily suspended, all these pointers must be saved so that a read call executed after the process is restarted will read the proper data. In many operating systems, all the information about each process, other than the contents of its own address space, is stored in an operating system table, which we usually call as the process table, which is an array or the linked list of structures, one for each process currently in existence. Okay, we've talked about this one. Associated with each of the files, the pointer again the current position. So now, when a process is temporarily suspended, all these pointers, they must be saved so that a read call executed after the process is restarted will read the proper data. In many operating systems, all the information about each process, so about each process meaning we are talking about the applications that are currently running on the device, so other than the contents of its own address space, it is stored in an operating system table, which we usually call the process table, which is an array or linked list of structures, one for each process currently in existence. Okay. So a suspended process consists of its address space, which is usually called the core image, and its process table entry, which contains its registers, among other things. Okay, so now on this part, how the files, like how the documents or applications programs are processed, we'll be able to make something that will help you to understand more what we mean by core image, the table that is used, and also when something goes into suspension, what happens before they are executed. Okay, so now the second one, we're saying a process called the command interpreter or shell reads commands from a terminal. So the terminal that we're talking about here can be that black interface we are seeing for entering what commands from a terminal. So the user has just typed a command requesting that a program be compiled. The shell must now create a new process that will run the compiler. So we've defined what a compiler is. When that process has finished the compilation, it executes a system call to terminate itself. This is what usually happens when something is done executing. So it will execute a system call to terminate itself, so that it also allows other programs now that are in the queue to also start processing. So if a process can create one or more other processes, which we are referred to as child processes, and these processes in turn create child processes. Okay, so we're done with the process. Let's see if there are any questions, but feel free, if there are any questions concerning the processing, please let me know. You can just write the questions in the comments, or you can just email for, especially for the notes, those who want notes. I can be able to share some of these notes so that when revising it will be very easy for you. Okay, so now we go to deadlocks. So when two or more processes are interacting, they can sometimes get themselves into a stalemate situation they cannot get out of. Such a situation is called a deadlock. So when two or more processes are interacting, they can sometimes get themselves into a stalemate situation, which we are calling the deadlock. So now for this definition, or this statement rather, be able to give examples concerning this statement so that it will be easy for you to understand what we're simply talking about here. Okay, so processes in a computer can experience an analogous situation in which they cannot make any progress. For example, imagine a computer with a tape drive and CD recorder. So I'm sure you all know what a tape drive is. If you don't know, I'll be able to show you what the tape drive is and also how it works, and also the CD recorder. So now imagine that two processes each need to produce a CD-ROM from data on the tape. Process 1 requests and is granted the tape drive. Next process 2 requests also and is granted the CD recorder. Then process 1 requests the CD recorder and is suspended until process 2 returns it. So show you're getting something here. Let me just go through again the example. Imagine a computer with a tape drive and a CD recorder. So we've got two things that are involved in this example. The first example, let's say that two processes each need to produce a CD-ROM from the data that is on the tape. So we have got two processes now, the process 1 and also process 2. So for process 1, it first requests and is granted the tape drive. The second one, we go to process 2, it also requests and granted the what? The CD recorder. Okay. So then process 1 requests the CD recorder and is suspended. So this process 1 gets the tape drive, while process 2 gets the what? The CD recorder. So now after the process 1 is done with the tape drive, it will need now the CD recorder. So now since this process 2 is still using the CD recorder, this process 1 needs to what? Needs for this process 2 to terminate or to finish what it's doing so that it can get now the CD recorder. Okay. So the process 1 requests the CD recorder and is suspended until process 2 returns it. So returns it meaning after it's done with the CD recorder. Finally, process 2 requests the tape drive. So now here they exchange now. This is so all this it's in line with the deadlocks. So they want to use some things now. They find themselves in a stalemate situation where they cannot get out, but the other option that they have is just to wait for each other, this one to finish, so that they can also again exchange. Okay, so this is the practical example. I'm sure it's self-explanatory here. Suspended because process 1 already has it. Here we have a deadlock situation from which there is no escape but to just wait. Okay, so if there are any questions, especially on this example, sure to some of you it may not be that clear, please comment in the comments. So the next one, we go to memory management. So the memory management, we're saying every computer has some main memory that it uses to hold executing programs in a very simple operating system. So only one program at a time is in the memory. To run a second program, the first one has to be removed and the second one placed in the memory. Okay, so now we cannot run more than one program at once in the memory, so it follows the logical order like that. It waits for this one to finish before it can allow the second one. The second one finishes, it brings in now the third one, just like that, and the process continues like that. Okay, so now more sophisticated operating systems allow multiple programs to be in memory at the same time. So sophisticated operating systems allow multiple programs to be in memory at the same time. So now, to keep them from interfering with one another and with the operating system, some kind of protection mechanism is needed. While this mechanism has to be in hardware, it is controlled by the operating system. So now, the above viewpoint is concerned with managing and also protecting the computer's main memory. A different but equally important memory-related issue is managing the address space of the processes. Okay, progress. So normally each process has some set of addresses it can use, typically running from 0 up to some maximum. In the simplest case, the maximum amount of address space a process has is less than the main memory. In this way, a process can fill up its address space and there will be enough room in main memory to hold it. However, on many computer addresses are 32 and also 64 bits, giving an address space of 2 to the power 32 or 2 to the power 64 bytes respectively. What happens if a process has more address space than the computer has main memory and the process wants to use it all? So now I'll be able to answer this interesting question now. So a technical called the virtual memory exists, in which the operating system keeps part of the address space in main memory and part on disk and shuttles pieces back and forth between them as needed. Okay, so we haven't talked about the memory management. We now go to input and output. So all computers, they have physical devices for acquiring input and producing output. So what we mean here by their physical devices for acquiring input, for example, we've got the keyboard. The keyboard, external keyboard, for example, we connect it first to the computer, and then we start entering the information or rather typing. So that process of typing information into the computer or getting maybe something from the flash into the computer, that process is called now inputting information into the computer. Okay, and producing the output. So the producing the output in maybe, for example, in form of display, like on the screen, the monitor. So the monitor also, what you have to know again is that we've got different types of monitors. So we've got about 3. We've got what we call the SCRT, the LED, and also the LCD. Okay, now we'll talk about the different types of monitor later on, but for now our main concentration is just on the input and also the output part. So now I say, after all, what good would a computer be if the users could not tell it what to do and could not get the results after it displays the work requested? So it would have been, it can't be of any use if we are not able, if the computer is not able to listen to the user's instructions or rather the commands. Okay, so the second one we are saying many kinds of input and output devices exist, including the keyboard, monitors, printers, and so on. So these are the important output devices that exist. So now it is up to the operating system to manage these devices. So now if you remember, when you go back to the definition of operating system, we said the function rather, we said that it is responsible for input and output management and also responsible for coordination of hardware and software. Okay, so now consequently every operating system has got an input and output subsystem for managing its input-output devices. Some of the input-output software is device independent, that is, applies to many or all input-output devices equally well. Other parts of it, such as device drivers, are specific to particular input-output devices. Okay, so now sure we can go back to files. We can now go to files. So another key concept that are supported by virtually all operating systems is the file system. As noted before, a major function of an operating system is to hide the peculiarities of the disks and other input-output devices and be able to present the programmer with a nice, clean abstract model of device-independent files. So the programmer in this case, we are simply saying that the person who writes codes of programs is referred to as a programmer. So the system calls are obviously needed to create files, remove files, read files, and write files. Before a file can be read, it must be located on the disk and opened, and after it has been read, it should be closed. So calls are provided to do these things. So the system calls. Okay, so now we learn how to create a file, how to remove files, also how to read and be able to delete files. Okay, so the last one under files, we are saying to provide a place to keep files, provide a place where the files are supposed to be kept. Most operating systems have the concept of a directory as a way of grouping files together. Okay, so the process and file hierarchies both are organized as trees, but the similarity stops there. Process hierarchies usually are not very deep. More than 3 levels is unusual, whereas file hierarchy are commonly 4, 5, or even more levels deep. Process hierarchies are typically short-lived, generally a few minutes at most, whereas the directory hierarchy may exist for years. Ownership and protection also differ for processes and files. Typically, only a parent process may control or even access a child process. So a child process, by this time you should know what we mean by a child process. But mechanisms nearly always exist to allow files and directories to be read by a wider group than just the owner. Okay, so we go now to the last part under the operating system concepts, which we are calling the security. Okay, so computers contain large amounts of information that users often want to keep confidential. Large amount of information that users would want to keep as confidential. So you know these types of files that we're talking about. It may be your academic credentials, your Facebook passwords, Gmail passwords. Yeah, so in a Gmail you use it to keep information which is very confidential, or files which you would want someone else to have access to. Okay, so that's where now the security party comes in. So this information may include electronic email, like you mentioned here on. So the electronic email, we use it mostly for communication purposes. We use it to keep files. We can use it to apply business plans. So business plan, if you don't want maybe someone to steal your business plan, meaning you have to put some measures of some security measures to make sure that that information concerning the business plans is not stolen. The tax returns and also a lot more examples can be given on this one. So now it is up to the operating system to manage the system security so that files, for example, are only accessible to authorized users. Okay, so now in this case we are simply saying the operating system, it is responsible to make sure that it provides that security part to the users so that the users' files are protected, especially those that we feel they are very confidential. Yes, so as a simple example, just to get an idea of how security can work, we can consider Unix. In Unix, so this we'll be able to talk about Unix. So files in Unix are protected by assigning each one a 9-bit binary protection code. The protection code consists of 3-bit fields, one for the owner, one for other members of the owner's group. Usually the users here are divided into groups by the system administrator, and one for everyone else. Okay, so we continue with the security part. So we are saying each field has a bit for read access, a bit for write access, and a bit for execution access. So these 3 bits, they are known as RWX bits. RWX bits. For example, let's say the protection code, it's RWXR-X-X, which means that the owner can read, write, and be able to execute the file at the same time. So other group members can read or execute, but cannot write the file. So they can only be able to view, maybe let's say if this is a document, other users, if it's protected, let's say there's a password, only the person who is the administrator can be able to modify or make changes to the file. But with someone who is not an admin, can only be able to maybe viewing the file. Okay. For a directory, X indicates search permission. A dash means that the corresponding permission is absent. So now this part will be able to demonstrate in the administrators, as we will log in as administrator to understand what these letters and the dash, what they simply mean. Okay, so in addition to file protection, there are many other security issues protecting the system from unwanted intruders. So the unwanted intruders here, they can be both human or not human. It can be maybe just a machine which is just programmed to be having access to people's information, or it can be humans who are, in this case, we can even use hackers who likes getting into other people's information, or who likes intruding other people's privacy and getting the important information which is very confidential to someone, and that's very unethical. So for example, viruses is one of them. So softwares, so computer hardware cannot perform a single act without instructions, so these instructions are known as software or computer programs. So the software is at the heart of all computer applications. So the system software, we talked about system software. So now these I'm sure they will be self-explanatory. You'll be able to understand what each statement means here. So the system software, we are saying it acts primarily as an intermediary between the computer hardware and application programs. So you understand, this is where I said now it is responsible now for the coordination of hardware devices and also the software devices. It is able to coordinate them so that they work together. And knowledgeable users may also directly manipulate it. System software provides important self-regulatory functions for computer systems, such as loading itself when the computer is first turned on. System software also manages hardware resources such as secondary storage for all applications and providing common use sets of instructions for all applications to use. Okay, abstract view of hardware and software. So the relationship between the hardware and the software, it can be viewed in the hierarchy or layered structure, which is here. So the first one, we have application programs. Second, we have operating systems, and also thirdly, we have the hardware. So the hardware, which is the hardware interface. The operating system is a beautiful interface because mostly it displays information that is easy for the user to interpret. Okay, so the system software, saying there are 4 main subdivisions in the system software. So the first subdivision we are talking about is the operating systems, another and control programs. The second is translators, utilities and service programs. Then lastly, the database management systems. Okay, let us start with the first subdivision in the system software. So computers are required to run automatically without continual intervention by the user. So control programs and operating systems are the means by which this is achieved. So these control the way in which the hardware used. Some computer control programs may also accept commands typed in by the user. Such a control program is often called monitor. It is common on some computer systems for only part of the monitor to remain in main storage. Okay. It is common on some computer systems for only part of the monitor. Other parts of the monitor are brought into memory when required, i.e. they are resident and transient. So the resident part of the monitor on large systems is often called the kernel. So the kernel executes and supervises the programs. An operating system, we're saying, is a sort of programs that operate the computer and allows other programs to run without human intervention. So other programs that are able to run without human intervention, for example, we can give an example of let's say Windows Defender, which is an antivirus which comes with an operating system. So it is able to detect files without user interaction and be able to present whatever it finds to the user, so that the user can now either take actions or some other things. Alright, so we also need to talk about the translators. So translators, these are computer programs that interpret instructions to those a computer will understand. Okay, so translators, they are responsible for translating instructions to a computer language, in short, so the language which the computer is able to understand. So now this is just the introductory part where the translators will be able to look into details. So the earliest computer programs were written in the actual language of the computer, but it's not so nowadays. Programmers now write. Alright, so we'll be able to demonstrate what each one of these means. Programmers now, they write their programs in programming languages which are relatively easy to learn. Each program is translated into the language of the machine before being used for operational purposes. So this translation is done by what we are calling the translators. Okay, so next, in the next lecture, we'll look at the utilities and service programs. So the common types of utility programs that we have, and we'll also talk about application software now, this time in detail. Okay, also be able to talk about the programming languages, levels of programming languages, advantages and disadvantages, assembly language. Now this time we're looking at them in assembly language. Also do a practical example like this one here. We'll now be able to understand what is happening here. High level language, system development, stages of life. Okay, so now this brings us to the end of today's lecture. Have a good day. Please, if you have any questions, let me know in the comments. But for now, we can end here.